Hi guys, how are you? Hey, this is going to be one of many videos that you might see throughout the school year, created by me, Mrs. Warner, your 6th grade math teacher. You're going to see me do things on my paper that are coming from your book. You may or may not have your book. If you don't have your book, then you're probably just going to want a piece of paper and a pencil. And you're going to want to be writing down the things that I'm writing down. Now, the good thing about the fact that we get to do this way is at any time I'm moving too fast, you can hit pause and then write everything down that you need to write down, and then just hit play and pick right back up. Or if you're like, oh, I'm not sure what she just said, you can also rewind. So it's perfect. It's great to be able to go at your pace and what works for you. So you're going to see that I'm probably going to look down a lot and I'll look up, but I'm going to be doing everything on this paper that you see in front of me that is hopefully in your book as well. Again, if you don't have your book, you're just going to want to write it on the paper. We're going to walk through a whole bunch of examples. I'm going to teach you different methods, different ways to get the answer, and you're going to eventually pick which one you feel like you understand the most of. So we're just going to go ahead and jump right on in. So if you have your book, open to page 7. If you don't have your book, piece of paper and a pencil. And we're going to go ahead and get started. So you're going to see I'm going to zoom in and zoom out a lot, but we are actually going to start on page 7, and we are actually working on factors and multiples. So here's the cool thing about this, our book, is you'll see that we have these highlighted words, which we know from context clues and from learning to read that those obviously are important words. So these are very important vocabulary words, and we're going to work on two things. We're going to work on factors and multiples. So we're going to work on what is called the GCF and the LCM. The GCF is known as, right here, the greatest common factor. And the greatest common factor means that it is the factors of 2 or more numbers. It's called the greatest common factor. When you take a look at the least common multiple, otherwise known as the LCM, it is a number that is a multiple of 2 or more whole numbers is the least common multiple. Okay, so what I want you to do is we're going to fill this in really quick. Okay, so GCF we know stands for, and you're going to go ahead and just write it down, greatest common factor. And you're going to notice that I have really bad handwriting, really bad. Okay, this is why I teach math. So you can laugh at me all you want. I have really bad handwriting. This is why I deal with numbers. So if you can't read it, I'm so sorry. You will get used to it, I promise. All right, greatest. Well, we know the greatest means the biggest. Okay, the largest, anything that we can think of. Common, well, if you have something in common with someone, you have something that is alike, otherwise known as the same. So you see how I wrote both words, alike or the same, doesn't matter. And factor, we learned up here that a common factor is a number that is a factor of 2 or more numbers. Okay, the greatest common factor, so a factor is, so we are multiplying numbers, and I'll abbreviate, numbers multiplied together to get a number. So, for example, I'm going to come over here. I'm going to give you a really good example of a factor so you know what that means. Okay, so if I said let's list the factors, we'll make it plural. Let's list the factors of 6. What numbers can we multiply together to get 6? Easy. 1 times 6, 2 times 3. So my factors of 6 are 1, 2, 3, and 6. Those are the factors of 6. Okay, so let's talk about LCM. LCM stands for the least common multiple. Okay, and least obviously means the smallest. Okay, and common, same thing. Maybe I can just draw an arrow, make my life easier, right? Make your life easier. And a multiple is, for example, like if we're starting with the number 3. Okay, so when we're talking multiples, I'm going to give you an example of this one. If we're doing the multiples of 3, I'm going to go multiples of 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. And this number list can go on forever. So my multiples of 3 are 3, 6, 9, 12, 15. So easy. So if I were to say, hey, let's list the multiples of 5. Well, that's easy. It's just counting by 5s. 5, 10, 15, 20, 25, 30. Okay, so we're going to go on to the next page. So you're going to go and turn your book. So I'm turning my book too. And I'm going to realize that I think mine is actually over on this side. Yes. Okay, so we're going to talk about greatest common factor. And the thing is they're going to give you a couple of examples. And I'm not going to walk through these examples, but rather I'm just going to show you really quickly, and then we're going to practice one. Okay, so here is talking about different kinds of cakes and the number of serving sizes that they come in. And if we're going to talk about cake, we have to talk about my all-time favorite, cheesecake. Oh my gosh, if you don't like cheesecake, I don't know what is wrong. I love me some cheesecake. So whenever we talk about cake or food, you're going to realize I talk about a lot of things. So let's talk about factors. The factors of 10. Notice they've listed the factors of 10 are 1, 2, 5, and 10. Okay, because 1 times 10 is 10, 2 times 5 is 10. They listed the factors of 15, and they listed the factors of 20. Now, notice what they did in this red area right here. And I'm really trying to circle that. So you see that they have circled numbers that what? That they have in common. So every single one of these rows of the factors of 10, the factors of 15, and the factors of 20 all have the common factor of 1 and 5. Now, remember we are talking about the GCF. That G stands for greatest. So the common factors that 10, 15, and 20 have are 1 and 5. But is that the greatest common factor? No, what is the greatest common factor? What's the bigger number of 1 and 5? 5. So the greatest common factor of 10, 15, and 20 is 5. That's the greatest common factor. All right, let's take a look at A, because I really like doing these problems together. Okay, so A says, Lana earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? So we're going to need to list the factors of these numbers. So we're going to list the factors of 49. Okay, so numbers that I can multiply together to get 49. Always start off with 1. 1 times 49, 2, nope, 3, no, 4, nope, 5, nope, 6, nope, 7, yep, 7 times 7. And these two numbers, 7 and 7, are the same number, so we're done. That's all we're going to do. So the factors for 49 are 1, 7, and 49. Okay, let's list the factors of 42. 42, 1 times 42, 2, yep, 2 times, 2 times 21. Sorry, sometimes my pen has a mind of its own. 2 times 21, 3. Sure, 3 times, who's got it? 14. Okay, 4. Nope. 5. Nope. 6. Yep, 6 times 7. Okay, so the factors, notice there's more factors for 42. We have 1, 2, 3, 6, 7, 14, 21, and 42. Sorry, I kind of ran out of room. You'll see that happens. Okay, so I've done 49, I've done 42. Let's do 21. I'm going to do 21 over on this side over here. So 21. Again, if I'm going too fast, hit pause and then come back to it. So 21. 1 times 21. 2, nope, 3, yep, 3 times 7, 4, nope, 5, nope, 6, nope, 7. I'm back to where I started. So here these are 1, oops, not 2, 1, 3, 7, and 21. So now I'm going to circle the ones that they have in common. I feel like this is kind of, I need to thin it out a little bit. Okay, so I know that they all have a 1. I notice that they all have a 7. And that's it. So my greatest common factor of 49, 42, and 21 is 7. Okay? All right, let's move down below. And we're going to work on prime factorization. I love doing prime factorization. Okay, we're going to try to find the GCF of 12 and 18. Here's how you do it. You're going to see that they took 12 and they broke it down into two factors of 6 and 2. Okay, 2 is a prime number, meaning it only has one in itself that you can multiply it by. So if I were to list the factors of 2, it would be 1 and 2, right? If I were to list the factors of 3, that would be 1 and 3. Those are the only numbers I can multiply together, whole numbers that I can multiply together to get that number. So when they broke it down here, switch back to my black pen. When they broke it down here, they broke it down into 6 times 2. They brought this 2 down here because I can't break that down any farther. It's as far as it goes because it's a prime. But I can take that 6 and break it up into 3 and 2. So my prime factorization for 12 is 3 times 2 times 2. And if we do that math, what's 3 times 2? 6. What's 6 times 2? 12. It gets us back to that number. So this is called prime factorization. So now they did it with 18. And they noticed when they got it to 18, the prime factorization was 3 times 3 times 2. So here's what you do. After you broke it down, you see what numbers they have in common, and we're going to circle them. They each have a 3, and they each have a 2, which means I'm just going to take 3 times 2, and that's going to give me 6. So my greatest common factor of those two numbers is 6 using prime factorization. Okay, so here's what's going to happen. We're going to do 2 of these problems, and then we're going to jump over to least common multiple on the second part of this video, okay, because I like to spend some time doing a couple of examples so you know what you're doing. So let's take a look at these. So this first one, let's do for 12 and 66, let's do prime factorization. Okay, and you're going to see I might run out of room, so I kind of had to pull it down a little bit, which is fine. You guys have plenty of writing room over here, over on the left-hand side, but over here we're going to go ahead and do the prime factorization over here on the left-hand side. So I'm going to write 12, and I'm going to figure out what two numbers can I multiply together to get 12. Well, I can break it down to 3 times 4, right? So I'm going to do 3 times 4. Can 3 get broken down any farther? No, it can't because it only has 1 and 3. So 3 is going to stop. I'm stopping at 3. I'm just going to circle that one because I know that I cannot break that down any farther. I can go down to 1 and 3, but there's no point. So let's break down our 4. What two numbers can I multiply together to get 4? Besides 1 and 4, right? I can do 2 times 2. Now, can I break down this 2 any farther? Nope, I'm going to circle it. Can I break down this 2 any farther? Nope, so I'm going to circle it. So here my prime factorization for 12 is 2 times 2 times 3. Okay, now let's do it for 66. Okay, let's go ahead and break it down into, it can really be whatever you want it to be. Let's do 11 times 6. It doesn't matter what two numbers you start with, what two factors, you're still going to get the same answer. That's what's so cool about this. Okay, 11. 11 I know is prime because the only numbers I can multiply together are 1 and 11. So I'm going to circle that one and be done. Now I'm going to break down the 6 into 2 times 3. 2 I know is prime, so I cannot break that down any farther. And 3 I know is prime, so I cannot break that down any farther either. So now I'm going to list this out. 2 times 3 times 11. Let's circle the ones. They have a 2, yep, and they have a 3. So 2 times 3, I'm just going to take a 2 and a 3, which gives me 6. So the greatest common factor of 12 and 66 is 6. Cool, right? Okay, so now let's go ahead and move to this example on C. So instead of doing prime factorization, we're just going to list out the factors. So 18. 1 times 18, 2 times 9, 3, nope, 4, nope, 5, nope, 6, oh, 3, I'm sorry, yes, 3 and 6, yeah, 3 and 6. Sorry, Mrs. Horner, I missed it the first time. See, this is why I go through. 4 and 5, good. Okay, there's my prime factorization, or not my prime factorization, there's me listing my factors of 18. So let's list the factors of 30. 1 times 30, 2 times 15, 3 times 10, and then